Then new topic is about momentum. How we define momentum or definition of momentum. Momentum is it is product of mass and velocity. When mass and velocities are multiplied with each other, what we get? We get momentum. The formula for momentum is equals to mass multiplied by velocity, and the unit of the mass is kilogram and the unit of velocity is meter per second, so it is kilogram meter per second, and it is a vector quantity. When we say it's a vector quantity, it means it is having a direction, or we can use a vector addition rule to get the resultant. So if an object is there of mass 2 kilogram moving with a speed of 5 meter per second, so we can find its momentum. How? The mass multiplied by velocity, so 2 multiplied by 5, that's equal to 10 kilogram meter per second. And the direction of the momentum will be same as the direction of the motion, the point where the object is moving. Then the change in the momentum. The change in the momentum is also known as impulse. It's also a vector quantity. So how to calculate the impulse? Impulse is equals to the final momentum minus initial momentum. The difference in the momentum will give us the impulse. Impulse is denoted by I. The final momentum, basically what happened, like if there's an object of mass m, it might change the direction. So if it does not change the direction, so if initial velocity is u, the final velocity will be v, because this is one possibility, that the direction does not change. But there's also another possibility that the direction of the motion might change. If the direction of the motion may change, if object is moving towards right with a velocity of u, it can bounce back after striking a surface. So final velocity, the magnitude change, but we will take as minus, because when the direction changes, it should be in opposite. So here, for the first example, it is mv minus mu. But for the second example, it will be, because the momentum is minus mv, the final minus the initial momentum is minus mu. And the unit of impulse, the unit of impulse is same as the units of momentum. You can also take like kilogram meter per second. Also, there's also another unit, that's Newton per second. How it is Newton per second, the other unit for momentum, sorry, impulse. So it can, normally we use Newton second, but it can be kilogram meter per second as well. As we know, F is equals to ma. The formula, force is equals to mass into acceleration. And acceleration is a change in the velocity. So we can write v minus u over t. If mass is multiplied with v, so F is equals to mv minus mu divided by t. So time is divided, other side it is multiplied. So F into t is equals to mv minus mu. And mv minus mu is a change in the momentum, which is also known as impulse. So we can say force into time is equals to impulse, or impulse, the force which we applied and for how long this force is applied. So that's why its unit can be Newton per second as well. So it can be Newton per second, or it can be kilogram meter per second. And the rate of change in momentum, you can see this part, the rate of change in the momentum is equal to the resultant force. So if we have a graph between force and time, it can be a linear graph or a non-linear graph. So if it's a linear graph or non-linear graph, sorry, so the area under the graph, because area is the product of quantity on x-axis multiplied by y-axis, or y-axis quantity multiplied by x-axis. So on y-axis we have force, on x-axis we have time, so force multiplied by time. So area under the graph of force and time, what it will give? It will give us impulse or change in the momentum. The area, and how to find area of a non-linear graph, we'll divide this into equal parts, horizontal and vertical, and find area of each. So it will be approximate, not an exact answer. Then conservation of the momentum. Conservation of the momentum in isolated system. Isolated system means a system which is not experience any external force. So isolated system, the total momentum before collision is equals to the total momentum after the collision. So total momentum before collision is equals to total momentum after collision. So example, you have two objects of different masses, or they may have identical mass. So M1 and M2 are the two objects, and they're moving with velocities, say u1 and u2. They come in contact, collide with each other. So the masses will not change, but sometimes the object may stick together. Sometimes one object might be stationary, the other is moving. Sometimes they might change the direction. If they change the direction, then I should use a different like negative sign for the change in direction. So it is M1 and M2. So what is the momentum before they collide with each other? The total momentum before collision, the sum of the momentum. So that's equal to M1 U1 plus M2 U2. And momentum after collision is M1, this is after, M1 V1 plus M2 V2. So if isolated system, like there is no resultant for, there is no force which is opposing the motion, the friction, the air resistance. So the momentum before collision for the system, which is M1 U1 plus M2 U2, is equals to M1 V1 plus M2 V2. This is known as the conservation of the momentum in one dimension. In this part, like in AS physics, you will study in one dimension, and in A2, you will study the conservation of momentum in two dimensions. It's the same thing, same way you will solve the questions. I will share, first I will share the assignment related to O levels momentum, so you can recall the idea, and then the A level questions. So any doubt related to the class today? Because this was a same topic you took in O levels, and there's no extra thing in this momentum. That's why I did not go in detail of that. Any doubt related to the class today? Okay, so I'll end the session. This week I will share the projectile assignment with you. This is the projectile is a very important topic, so I expect everyone submit on time and discuss the doubt next week.